To be honest, Internet of Things, if I make a wrong write to a certain register on the certain device, I can literally burn something. There were projects I worked on where we had hundreds of thousands of units of individual x86, 8 gigabyte of RAM, 4 core machines across the world. And so what I learned very early on is if you're going to do this securely, you need to partition the hardware and have trust. And to be honest, it scared me. I think day one, I was like, this is going to blow up a building.
Obviously, like more complex, multi-agent orchestration and architectures. Where do you think the dangerous trust boundary failures there are that will emerge?
It's interesting because I think that the biggest risk is actually more of a human problem.
Thank you for joining the Resilient Cyber Show. My name is Chris Hughes, and today I'm joined by Alex Zenla. Alex, thanks for being here.
Yeah, thank you so much. It's great to get here to chat. So yeah, excited.
Yeah, likewise. I'm already familiar with you and the team, but for folks that don't know you and haven't followed the Adera team, can you tell us a bit about yourself and the team as well?
Yeah, absolutely. So I started in tech pretty early in my life. I was working on open source when I was like 11 or 12 years old. My father was worked in IT, and so I kind of got to know computers because of that. And eventually I ended up starting a tech career at the age of 14, which is just absolutely nuts. I grew up in the state of Alabama and here in the US, so not something you expect when you're a kid there. Ultimately, it through a series of things related to the Internet of Things industry, I ended up working at Google on Internet of Things across their real estate and workplace services teams. So we were doing things like monitoring the power usage and the solar systems, and the HVAC was a big one as well as just sensors and things like that. So I spent, I don't know, 10 years doing stuff like that. And ultimately, I ended up kind of working more on like the operational side of how you deploy those applications. And I have always been an open source person my entire life. I, started with Chromium and Chromium OS and worked on the Dart programming language. I just, have a love for computers and software. And ultimately, I started working on this technology for sandboxing a little over, I think it's a little over 2 years ago now, just in my free time, because I actually was needed it for stuff that I was doing at Google, and there was just nothing on the market at the time. Like it was you had things like Google's gvisor, you had Kata containers and some like open source projects, but nothing felt polished. And ultimately, I knew Ariadne. Ariadne was one of the creators of a lot of the technology behind ChainGuard. Worked on Wolfie over there, kind of built that up from nothing to something. Also worked on Alpine Linux and has a portfolio that you are using her software right now. Let's put it that way, that kind of thing. And I had known her for many years, and I showed her what I was doing, and she was like, "This is the next big thing." So then Emily, CEO of Adera, the company that I eventually founded for this. I met her actually we met on February 14th, 2 years ago for the first time. It was supposed to be a 30-minute call, and it turned into a 3-hour call. And we knew immediately that we were going to be friends and completely aligned on doing this business together.
That's amazing. Yeah, yeah. Anyone that has looked into your bio, and myself included, I kind of felt like a Neanderthal after that. I was like, I'm somewhat technical, but I was not doing some of the things you were doing at the age that you were doing them in.
Yeah.
So it's an amazing background for sure. And you all have this kind of market validation that's kind of going on right now. Like you guys had this contrarian bet where you started building like this isolation technology, 2 years before the latest AI agent sandboxing craze hit. And in the blogs you guys have, you talk about IoT. Some of the stuff you just mentioned, like heating systems, controllers, where security failures put human health at risk. What did you see in the IoT world that made you convinced that containers were, kind of fundamentally broken as a security boundary? And how did that translate into, wanting to found the company here?
Oh, this is such a good question. So it's important to know that the Internet of Things is such a homegrown industry in a lot of ways. Everything is built by necessity. Very little of it is actually well planned. Like if you just look at the companies in the industrial IoT space in particular, you tend to find a lot of, I would say, traditional engineering, like mechanical and electrical engineers, who maybe do software on the side out of necessity. The vast majority of companies that I worked for, startups, were kind of trying to capitalize on this idea that if you came out at it from a software angle, that you could do a lot of things differently. And so we were doing no code solutions and data flow and this idea of like connecting dots together to make data flow from one place to the other. Like all of that hype that happened, I would say maybe like a year or 2 years ago, of the no code craze and all of that. We were doing that 10 years ago. And with that comes autonomous systems. I would say that for the first 6 years of my career, it was still deterministic. Like you still were taking inputs and deciding outputs based on the inputs deterministically. But that changed very quickly. I was part of a project at Google. I was sort of affiliated with it, and that was all about bringing machine learning into driving decisions about how things like heating a building or cooling a building happen. And to be honest, it scared me. Like, I think day one, I was like, this is going to blow up a building. Like, I legitimately thought, like, if you tell a computer to just make a decision, it's going to do a bad thing. Because to be honest, Internet of Things, if I make a wrong like write to a certain register on the certain device, I can literally burn something, right? Or I can accidentally shut off the electrical by overpulling power. So the risk is huge. And the other constraint is that it's all edge systems. I know that some of your viewers are in the defense industry, and well, that's a very common thing in the defense industry. And edge systems have so many unique challenges. One of them is that they're often deployed in places where humans aren't necessarily well equipped to manage them. Like, the average person who's going and dealing with a piece of hardware is maybe not a software engineer. And that comes with all sorts of constraints and things to think about. Physical access is also a concern. How do you make sure that this physical security of the system isn't compromised, while still allowing it to do its software job? But then I would say the biggest problem that IoT taught me that gave me insight into this was scale. There were projects I worked on where we had hundreds of thousands of units of individual x86, 8 GB of RAM, 4 core machines across the world. And how do you deal with that? And the answer is that you end up having a network operations center and things fail often, right? But you also have this constraint of as technology started to get more popular, people needed to run more than one thing on these tiny pieces of hardware. And so, what I learned very early on is if you're going to do this securely, you need to partition the hardware and have trust. And as containers started to come in, what I realized very quickly is that in order for containers to function in these systems, they have to be completely rebuilt. And the reason for that is like if you go install Docker today, let's say, on just an edge system, that edge system, like there's all sorts of hardware that things need to connect to. I probably dealt with serial ports more in my life than anyone else, I swear. It was very common for us to have like one piece of software and another piece of software, and one be connected to one physical serial port and one be connected to the other. Docker just doesn't handle that stuff well because of the shared kernel. The Linux kernel is all shared across the entire system. So the fundamental theory that I had was if you wanted to do this right, you had to think hardware up instead of software down. I'm giving a many talks on this in the coming months, but I think a key thing insight I had is that most software engineers, when trying to deal with this problem, are looking from, my application and going down. But if you really want to solve the challenges and the security constraints of systems to prevent things like exploits from occurring or container escapes, you have to really go to the lowest level you can possibly comprehend and solve the problem up there.
I think
So,
that's you said something that made me think of something there. That, from the application down, the perspective that we tend to look at it, and I guess I'd be curious your perspective too. But I think that some of that's because a lot of the underlying primitives that are involved of making things function now have been abstracted away. Like we can
yeah,
rely on the cloud service provider, the platform engineering team. Like there's all these different entities that kind of abstracted a lot of the heavy lifting, undifferentiated heavy lifting, I guess you'd say, from the application development team away, that they've just been able to kind of forget about those things that they even exist and just focus on their application, right?
yeah,
And then you also you use the phrase least privilege is a phrase you used before a moment ago there, and non-deterministic agents. And I'm curious because your team had this a piece on the blog, I believe it is as well, where you said you fundamentally cannot apply least privilege to AI agents because the valid behavior space is unbounded. And I thought that was a pretty provocative claim, and it's for the security audience because things like least permissive access control have been a fundamental thing for decades, right, in our field. And you'll see people use phrases now like least permissive agency or least permissive autonomy, in the context of agents. But can you walk us through like why do traditional policy-based security models like SecComp profiles, AppArmor, network policies, et cetera, why do those fall apart when the workload is non-deterministic and can it install legitimate packages or write to arbitrary paths or make network calls that nobody predicted? Again, because it's non-deterministic, right? We don't know exactly what it'll do. It may do the different things in the exact scenario. It may do a different action. You never know exactly how it's going to happen. So why is that, longstanding principle of least permissive access control? Like, why does it not fit in this model?
it's a great question. So there's a number of reasons why, but I think an important point, kind of going back to my previous point, is that least privilege is really only able to be done in a way that what the privileges it can possibly do are, right? If you set up a setcomp profile, right, you may be limiting the system calls or the attack surface, but you cannot possibly predict any sort of jump that might happen, right? There's a fantastic article I just read from NVIDIA that mentioned actually that one of the biggest constraints is if you modify a configuration file, sure, you might be in a sandbox environment or have a setcomp profile set, but what happens when another user goes and tries to read that file? Could something execute there? Could it be delayed? Right? Like the constraint that I see is that there's so many possibilities. If you do least privilege in the traditional way, there's still so many possibilities of exploits. Because the moment you allow any, like, system call filtering is a great example of this, because what happens is people go, oh, I'm going to allow the system call, or I'm going to deny these specific system calls. But if you are talking about least privilege, generally you're allowing them. But it turns out that a lot of system calls are actually very vague. For example, open, read, write, those system calls can do anything. So then you're talking about restricting file system access. Well, the average engineer doesn't know enough about, for example, /sys on a Linux system. That thing can do anything. You can get arbitrary code execution out of /sys on Linux. No doubt. Like you can do things like modify kernel parameters and things like that. And of course, people do restrict those things and provide read only views of them. But I think also an interesting aspect is just the amount of data leak you can get is massive. I'll give an example. There was some like Docker based cloud hosting systems that accidentally can leak their UUID of the AWS instance they're running on because that is accidentally passed through the sysfs. And if you are running as root, you can just read like the UUID of the system, right? And so you can do things like, oh, I have two Docker containers running in completely separate tenancies. I can now determine whether or not they're running on the same physical machine, right? Like those kinds of leaks, it's just impossible to solve all those challenges unless you build from the hardware up the correct way to do it. If you try to go down and you try to think about the layers that you most understand, it's really hard. Like we in software engineering have kind of made engineers go from like vertically understanding their application to horizontally understanding their application. So, for example, if you're a front end engineer, you typically only focus on the web technologies. But, back in the day, people had to kind of be a little bit more vertical. Like you had to know how to sysadmin the Linux kernel if you wanted to run a PHP application, for example. Like that was a thing that people had to learn because the technology was too complex. But as
Yeah,
abstraction layers come to be, it's just it makes it so much harder.
yeah, we've definitely seen a strong push towards specialization, among most of the workforce. You had talked about the restrictions and so on before. I'm curious, like, I feel like we're seeing, again, like a long-standing kind of challenge in security where it's like the security capability trade-off, right? You could restrict X, Y, and Z, but it's the very utility of the thing that makes it so appealing to so many people. They want to use it, these agents, because they can read files, they can write, they can take actions, they can do all the things that a user can do. And as we further constrain that, it kind of restricts its utility, which kind of contradicts the entire thing, the reason people want to use it to begin with. Do you think that's fair to say?
Yes, absolutely. I think that the power of the AI agent technology is that they are unrestrained. And if you build it right, it's fine. Like if you build that sandbox, if you do the hard work, it really is fine to run those things unrestricted. And you can do so many things. Like I look at the technology that we build at Adera as sort of like a blast box, right? It allows you to literally explode something, and there is no concern whatsoever that it has impacted anything else. And I think that's a really critical thing. I'll give you an example of like why that's important. If you've ever used an AI agent, particularly Claude Code is like this, it will sometimes use its own tools, and then sometimes it'll just go like, "Oh, I'm just going to run the shell command." Like for example, when it goes and searches through files, like it has a tool to do that, but it'll also sometimes just run the find command, right? And that non-determinism of what it might actually execute means that if you just deny access to everything or only allow certain tools, the power of the LLM kind of reduces significantly. But if you open it up to free reign, but in a way that doesn't have actual material impact on the world, or your world, I should say, then I think it's so much more powerful. Ultimately, I think the most powerful AI agent system is something that runs in a vacuum and provides you the output without actually modifying anything on your system. And I think that's a really interesting thing that we're seeing people do at these sandboxes. And I think, the other interesting thing about it, though, is, we're doing this in development right now quite a lot. You've seen the explosion in the last month. But what happens when we actually deploy these things into production? And then the concerns and the things that you have to think about are suddenly 10x more than they were before.
Yeah, I love the framing of the blast box. I think it was you called it. It's like, we've heard phrases like limiting the blast radius, right, for quite a while in security and with the rise of zero trust and so on. And I think it seems much more practical than your earlier point of trying to constrain every possible action, every possible, it just seems like an unbounded problem, as we talked about a little bit earlier. And you mentioned Claude Code. You all had this piece on kernel isolation versus shared kernel containers. And I think you demonstrated that from inside a standard Kubernetes container, the agent can see like its entire, nodes, 12 gigabyte of memory, its host kernel version, etc. Where in a Adera zone, it can only see the allocation of memory that it has. It's running its own kernel. Besides that example, what are some other like eye-opening things that you've seen either from customers or red teams in terms of how agents, AI agents can actually reach beyond, if they're running that shared kernel infrastructure, like some risks in that scenario?
Yeah, I think the most powerful one that I have seen is when you talk about GPUs and hardware access. When you start to talk about things like the NVIDIA driver or managing NVIDIA devices, the stakes suddenly just balloon. And I think primarily, the way I think about it is this. NVIDIA systems were designed for rendering, right? They were designed to render a Pixar movie. They were not really designed for, running LLMs necessarily. And so the software stack reflects that. So, for example, GPU containers are a thing that are popping up, and people want to do things like have the AI agent go and spin up, system with a GPU and run, various different tools against it. When you start to do that, you realize the risk that you run into, which is if something faults on that GPU, you might literally break the GPU for the entire system. And so that sandboxing then with the shared kernel does not really hold very well. I think the fundamental thing to understand about that example, though, is that the shared kernel and the Linux kernel in general is what they call a monolithic kernel. It's it's designed specifically for things to have high impact. In fact, like basically, if you really dig into the internals, it really sees everything in a global namespace, right? If you have a process in one container and a process in another container, sure, there's like namespaces in Linux and C groups and all these things, but if as a kernel developer, I still can just go like struct process, right? Like they're the same thing to me. I see all of that context. And so the Linux kernel having that global context really allows for vulnerabilities to come up in the Linux kernel. We saw multiple different NVIDIA vulnerabilities related to like memory corruption, for example, that can occur even in an unprivileged sandbox with access to an NVIDIA system. So I think that's the most powerful example, but there's so many other ones. I mean, the data leakage is a huge one, but I also think that sandboxes are unique in that if you want that unrestrained AI agent stuff, you really need to turn off some of the security constraints that containers have. But you cannot do that well if you don't have kernel isolation, because the moment that you turn on like privileged mode, for example, suddenly you can just do anything on the system. You have like full root. But Adera's technology and other sandboxing tools that actually virtualize allow you to do is get privileged mode inside a safe environment so that you can do things like you can reboot, like for example, if you have an Adera zone, you can run the reboot command. It'll reboot the virtual machine, but it won't reboot your host system, right? If you turn on privilege mode, you can reboot actually the host system inside of a container today. So
Yeah, I think, and what's cool about what you're saying there is that, like, we've talked a lot about security, but that is tied to, business operation and disruption as well, like, beyond just security concerns of resiliency and uptime and business operations, et cetera. I wanted to ask you a question about the blast radius piece, and you've brought up NVIDIA, which is timely because I weave them in here. My next question is, researchers have shown that, you can manipulate like, say a README, right, to do prompt injection and execute malicious commands and bypass approval mechanisms, et cetera. And NVIDIA's AI red team, they also published a practical sandboxing guide that I shared recently. And in there, they said that shared kernel solutions are essentially insufficient for agentic tools. When you see that, that kind of thing come out from a leader like NVIDIA, does it kind of validate the thesis that you all have been building toward in terms of, how kernel level isolation is needed? And, if so, like also, how does it change like incident response activities when you think about that? You kind of touched on that before with like the restarting and so on. Like how does it reframe incident response like with this type of approach?
Yes, I think it's super validating for us to see that. And it's something that we've known for a while because, even though we may not have seen this exact AI agent world, I think anyone who claims that is just, not correct. What we saw is that non-determinism breaks the entire computing model we have, the way we think about computing. I think that arguably we have these problems even without AI. I think that if you are in a high security environment, these systems are still, humans can do everything an AI agent can do today, more or less, just way slower. And the amount of context we have is smaller. So, in theory, a human could wreak as much havoc as an AI agent, right? But there's someone to blame in that case, right? That's the ultimate difference. So the stakes are higher for that reason, but ultimately the problem was always there. But I think that it's an interesting landscape right now with the incident response side of this. Ultimately, what happens when things go wrong or you break something inside of a container? There's a lot of people who are in the Kubernetes space who probably are ashamed to realize that their SRE teams are cube cuddle execing into things way more often than you would imagine. The way that we deal with things is actually fairly manual today, I would say. But when you throw AI agents at the problem, if you were having an AI agent replace or supplement an SRE, SREs do what they do because they're often allowed to do things in production that us mere developers aren't allowed to, right? Like that's kind of the way I look at SREs are like the people who are given the golden keys. Particularly if you look at kind of Google's SRE kind of program, it's very much like that. Like the SREs have like direct connections into Google's data centers and their instant response environments, right? Like that's the kind of access that they get. And with AI agents today, the risk is huge because suddenly, if they're doing SRE as well, I mean, then a human has to come in and clean up the mess, and the mess might be far bigger than anything a human could do, right? But even outside of the SRE context, I mean, you're basically, I mean, particularly with like OpenClaw and some of the things that you've seen in the last few weeks, people are literally just giving complete full reign over their entire lives in software, hardware, and systems to these AI agents. And how do we even deal with that? Like I genuinely don't know if you give your credit card to OpenClaw, for example, a sandbox can't really help you there, to be honest. But if you could do things like restrict access to the APIs, for example. But the risk is huge, even just in these production use cases, I think. But I think ultimately what it comes down to is with our technology, if something goes wrong inside the environment that you have given the sandbox, you can just restart the sandbox and from a fresh start, right? Or whereas if you are running in a shared container environment, that AI agent might have found a way to do something really bad in another place. And suddenly your host system is just completely hosed. Like you might be running in a Docker container or whatever, but if you're able to do damage outside of the system because you gave it privileged mode to be able to do the maximum number of things that an AI agent can do, it might have deleted your home directory and all of your files. In fact, it might have even deleted all of your cloud environment files because, for example, on Mac OS, iCloud Drive is mounted. If you store anything in iCloud Drive or Google Drive and it's mounted on your host system, you can't even trust that. So the risk is absolutely huge.
Yeah, it's actually not to make fun of it, but it's funny you said that because a security leader in my network was on LinkedIn recently complaining that an AI agent deleted their entire iCloud like family photos.
Yes.
And it was exactly what you just described. Obviously, it wasn't tied to a business, but
Right.
just to show you the risk that could happen there.
Yeah.
So I wanted to ask you too about, kind of like MCP, multi-agent architectures and kind of the trust boundary implications there. You have maybe you will have situations where you have like single purpose-built agents running in their own isolated zones, controlled inputs and outputs between them, and we're seeing the rise of MCP adoption and that accelerating as well. We'll see obviously like more complex, multi-agent orchestration and architectures. Where do you think the dangerous trust boundary failures there are that will emerge? Is it agent-to-agent communication, tool use, data retrieval from external sources, or something else entirely? Like, how do you think about those kind of architectures?
It's interesting because I think that the biggest risk is actually more of a human problem, which is when the complexity gets turned up with multi-agent systems, it suddenly goes from I'm able to monitor what Cloud Code is doing because it's more or less a single thread. Like, actually, the best example of this is, have you ever been at a one-person company or like a few person company in Slack, and it feels very manageable, right? Suddenly you grow to 100 people, you cannot keep up, right? That's what's going to happen is we're going to get overloaded, and kind of like alert fatigue, we're going to get a little bit more relaxed on what we allow. So I think that's actually the biggest risk here, is that we get too comfortable, and then suddenly when things are fine until they're not, right? And I think that is the biggest damage that is going to happen from a human level. But from a technical level, I would say similarly, when you suddenly get these multi-agent systems to the complexity that people are doing, I'm thinking of Gastown in particular, where it's just insanely complex. And you suddenly get to the point where you cannot possibly monitor the permissions that you are allowing through that system. And ultimately, people want to be able to run. I mean, I can't tell you how many LinkedIn posts I saw that were like, I wish I could run dangerously skip permissions on everything, you know? And if you want to be able to do that, you have to have the sandboxing system, right? But ultimately, the risk is still there if we get lazy as humans and just allow no oversight. But I think also if AI agents are going to exist long term, they will be more autonomous than ever. I would argue that uh, you know the casual user who may be listening to this right now may not fully have this problem yet. But when you start to see these things deployed in prod, maybe replacing people or something like that, the risk is just astronomical because suddenly there is no possibility of oversight whatsoever. But I think also LLMs are so non deterministic that it just, you literally can't predict anything that it might do ever. You can ask it to do one thing and it will completely spit out a completely different thing. And I think that is just multiplied. I look at it as just multiplying the risk.
Yeah, yeah. It's not even to be honest with you, it's not even theoretical. It's realistic. Like Anthropic had a great report last week. I thought was super cool for them to release. It was called like measuring agentic or agent autonomy, I think it is. And they showed in there that as people use Claude Code more, like I think it was 100 or 1,000 sessions, I forget the exact number, but basically at that point over 40% of them are on full auto approve, like they're not even
Right.
they're not reviewing anything anymore. And it doesn't mean that they're necessarily more experienced as a practitioner, like they're more senior. It just means that they've gotten comfortable with using it,
Yeah.
and more, as you just said, they kind of just implicitly trust it and they just auto approve whatever. They don't want to see the details, just run, please go do. And they don't want to know necessarily all the nuances, and there's no way for human users to know exactly what's going to happen or how that's going to work out. They're just implicitly trusting the technology. And safe to say it can go wrong.
Right.
It can go wrong. So as we come to the end of the interview, I wanted to ask you, you all, what comes next for open source, like in the future of secure compute? You all recently announced some new functionality. I think it's, I may pronounce it wrong, but Styrolite, I think it is an open
Sorry.
source,
Yeah.
yeah, sandboxing tool that you all have out there. You're also on AWS GovCloud and so on. I know you guys are making some push in the like public sector, federal markets, and so on. Like as AI agents move from developer tooling experiments and these cool things that you see people tinkering around with to really production enterprise deployments, government workflows, and so on. How do you see this evolving, and not just for teams that have deep, like say Kubernetes expertise, but beyond that, like what's the vision there for secure by design infrastructure in the next say 2 years?
Yep, absolutely. So I have long dreamed of having a new way of computing be accessible. And I think what's interesting is like Adera actually did not start out as Kubernetes at all. Like what we realized is that people were adopting Kubernetes and we wanted to bring the secure computing to them. Ultimately, our foundation is secure computing wherever you are, whatever you are doing. And actually, if you look at our product, Kubernetes is an entry point, but you can use it the primitives however you want. We have APIs and CLIs and everything to be able to do whatever you want. So ultimately, my what I see as the future for us is being that kind of substrate across all of what you're trying to do with your computing environments when it comes to security. The way that I look at it, so we have an open source commitment where every release that we do, we try to do something very big in open source. A few releases ago, we made a bootloader called Sprout that reduces boot times significantly for AI systems, which tend to have lots of hardware resources. This time around, we made some changes to Styrolite that allow you to do things like jailing applications with a shared kernel, but it's actually the same technology that allows us inside of Adera to jail applications between our zones. So we are really trying to bring those components of our system more accessible to people who want to kind of play around with the bits of the technology. We have our hypervisor that we have built as well that is open source. So we care a lot about giving back to the community, but also we really care about your production systems. And the reason why is because if AI agents are going to succeed, they are going to exist on the developer systems today. And I would argue that the vast majority of AI agents that are being deployed today are on people's machines. When that gets deployed into actual production environments, everything changes. Suddenly you're talking about the stakes are way higher. You can't rely on shared kernels. You can't rely on kind of it's good enough kind of stuff. But more than that, integrations with your existing system. My fundamental belief is that if AI agents are going to succeed, we're going to have to manage them in a way that's awfully similar to the way we manage applications today, but just safely and more locked down. So I fundamentally believe that if we are going to succeed at doing secure computing, we have to be able to meet you where you're at because organizations do not just change overnight. They adapt, right? And so anyone who is trying to build a parallel universe, I really encourage you to look at it and go, we talk a lot about at Adera about on ramps. Like we care a lot about allowing people to on ramp into a secure future rather than building this kind of alternative model and begging people to come to it, right? And it's a fundamental belief of mine that if we're going to do that correctly, we have to really, really think about how that on ramp occurs. And I think that people are undervaluing that part of the system today. I think there's a lot of people who are focusing on only the developer story when the whole entire story, the whole life cycle is most important. So that's
Yeah.
what we're doing here at Adera.
Yeah, I think it's well said, especially coming in the public sector, myself, organizations tend to move incredibly slow sometimes,
Yeah.
and it needs to be approachable and something that's digestible for the largest, most complex environments. And I also, to your point about, it is pervasive in the developer sense of the endpoints and so on, but it's going to change fundamentally when you're talking, enterprise workloads and environments and things like that. So you all are up to some amazing stuff there. Adera.dev, Edera.dev. Definitely check them out. And Alex, thanks so much for jumping on and chatting with me.
Yeah. Thank you so much. I appreciate it. It's been a great discussion.
Absolutely. Take care.
Thank you.